Now, this illustration deals with supply-side equipment in accordance with 250.142A1. The very top illustration, notice that we have the main building, number 1. We have a separately derived system installed in building 1. We tap off of the secondary side with conductors supplying a panel board, and it's either a 10-foot tap, 25-foot tap, over 25 foot up to 100, over 100 to any length. And we're using the rules of 240.21C as in car, and 240.92C as in car, E as in Ed. But notice the grounded neutral conductor in the panel board at the very top, supplied by the separately derived system. 250.142A3 is in Apple, and 250.30A1 under the rules and requirements listed there, we could use that grounded conductor as an equipment ground and as a neutral and as a bonding conductor. But we would have to follow naturally the rules that are listed there. So the transformer is grounded there at the service equipment, not the service equipment, excuse me, but at the secondary side of the transformer. Now, the grounded conductor in the service equipment complies with 250.24C1 and 250.142A1. So all of that boils down to is 250.142A1. We can use that grounded conductor to bind a weatherhead, the service raceway, the meter to the equipment, which is earth grounded. And then, of course, the grounded conductor is sized by table 250.102C1, then calculated as a neutral conductor if that's a neutral load present by 220.61. Then the larger of the two is used, either table 250.102C1 size or 220.61 size. And then you see the grounding electrode conductor is 250.66. Either A through C or table 250.66, and the electrodes are selected from 250.52A1 through A8, and if you had 2 or 3 of them present, they're bonded together for the electrode system. And then we have rigid non-metallic conduit supplying that building 2 from building 1. So we have an outside feeder that's run over to that panel board that's in the second building, which has to be rated as service equipment. Then notice 250.30B1 exception, with this being existing wiring and everything, we can use that grounded conductor as a neutral equipment ground and a path for the fault current to travel over, an effective ground fault path. Notice it's bonded to the can or the enclosure, connected to earth ground in accordance with 250.142A2, 250.32B as in boy 1 exception, and we would naturally look at 250.122, and it would have to, the equipment ground would serve as an equipment ground and neutral and bonding conductor in this case. And notice it is earth grounded over at building number 2. Now, this is an outside feeder. So we know we could also apply, look this up on your own and in your code book, look at 225.32, exception 1, meaning as many mains as you wanted at that building. Because remember, at the building to the right, that's not necessarily service like the building to the left. So look at 225.32, exception 1, then sizing the conductors and overcurrent device for that feeder, since it's outside, would be 215.2 A1A and 215.3 because we're referred from Article 225 to this section for the sizing of the overcurrent device and the conductors. So as we pointed out now, or we're pointing out again, to the right there in boldface, supply side, in accordance with 250.142 A1 through A3. And this illustration is illustrating a separately derived system grounding where everything is in the same building. And then also this illustration is illustrating where you'd route a feeder from building 1 to building 2 and how the grounding would take place and have to be complied with, as well as the grounded conductor being able to be used as a neutral, equipment ground, and bonding jumper. And that's what this figure 16-125 is illustrating.